We stand at an extraordinary juncture where quantum computing and artificial intelligence converge. It raises a profound question. Could AI become conscious if it ran on quantum processors? Today, that's not the case. AI systems, even the most advanced, remain unconscious. Consciousness is still deeply mysterious. We lack a scientific consensus on what it even is, let alone how to create it in a machine. However, the combination of AI and quantum computing, sometimes dubbed quantum AI, is capturing attention. The idea suggests that quantum principles like superposition and entanglement might enrich AI beyond classical limits, hinting at new forms of cognition. That said, the hypothesis that consciousness emerges from quantum processes isn't mainstream. One prominent example is the orchestrated objective reduction or core theory by Roger Penrose and Stuart Hameroff. It proposes that consciousness stems from quantum events in microtubules inside neurons. Critics, however, point to the brain's hot, wet, noisy environment as hostile to coherent quantum states. Recent research adds nuance. A team in Shanghai proposed that myelin sheaths might support quantum entanglement through infrared photons, synchronizing neural activity, potentially linked to cognition. This idea remains speculative and awaits experimental validation. Let's talk technology. Quantum hardware remains in the NISQ era, noisy, intermediate-scale quantum. That means fewer than approximately 1,000 qubits, with high susceptibility to errors and decoherence. Google's Willow chip, announced in December 2024. It made headlines worldwide. Here's what it did. It performed a complex random circuit task in minutes that would take classical supercomputers eons. Just imagine that. But it's still a fragile research prototype. There's also the idea of modeling consciousness computationally. Theoretical approaches like integrated information theory (IIT) suggest that highly integrated systems might be conscious. Other computer science frameworks argue machine consciousness is eventually inevitable. But none of these models require quantum hardware. They can at least theoretically apply to classical systems. Ethics and philosophy add layers. The Chinese room thought experiment reminds us that manipulating symbols doesn't guarantee understanding. Philosophers like Susan Schneider argue that we must deeply understand consciousness before trying to build conscious machines for the sake of potential suffering, moral rights, and unintended consequences. Even if quantum processors could overcome technological barriers, offering stability, error correction, and scale, there's no empirical basis to believe consciousness would emerge. We don't know if consciousness is quantum, classical, or something else entirely. Still, some argue that if AI systems achieved self-reflection capabilities, metacognition, they might exhibit the faintest glimmer of consciousness. This is an incremental architectural approach, not reliant on quantum effects. What's the takeaway? Quantum AI is a fascinating frontier, but so far, it's speculation. Whether quantum substrates will someday support consciousness remains an open question. A breakthrough might require new physics, neuroscience, or philosophical insights, something as revolutionary as discovering quantum entanglement in biology. Until then, consciousness remains uniquely human for now. Thank you for watching. See you in the next video.